Hi guys, we're going to do something today that's a little bit tricky. I'm going to put the camera right on the paper. Follow along, you'll get it. I know you will. All right, let me get the camera set. Here we go. If you follow these steps, it really isn't bad, okay? There's our paper. It's basically addition and subtraction. You just have to remember that whatever you do it the entire way across. So we're doing a system of equations by elimination. So what we want to do is we want to eliminate one of the two variables and solve for the other. All right? And we do this by a means of making sure that either the x or the y have the same coefficient, and in this case 2y has the same coefficient in both. If one is positive and one is negative, when you add those together, those will cancel out or eliminate. Okay? And that's what we want to do. Alrighty, so here we go. I'm just going to pretend like I'm adding or subtracting. In this case, I'm adding. I'm going to add this to this, or my 4x to my negative 2x. I'm going to add my positive 2y to my negative 2y, and then I'm going to add my 6 to my 6. So this technique, we're going to use addition. You'll see another one in a moment where we can use subtraction, but I'm going to add each term with a corresponding term in the sentence above it. So 4x plus a negative 2x is 2x. A positive 2y plus a negative 2y is 0. And all that equals 6 plus 6 is 12. So I have 2x equals 12. I divide both sides by 2. That gives me x equals 6. And I am good to go. All right? Now, I'm going to take this x and I'm going to plug it in, it doesn't matter which one, into either one of these two equations. All right? So, I think I'll pick the first one so I don't have to negotiate as many negatives. And I've got 4 times my x, which is now 6, plus 2y equals 6. 4 times 6 is 24, plus 2y equals 6. Okay. I'm going to subtract 24 from both sides. You can do it vertically or horizontally, whichever way you prefer, and you know me, I like it going up and down, or vertically as opposed to horizontally. Okay? 24 minus 24 is 0. That leaves me 2y equals 6 plus a negative 24 is a negative 18. I divide both sides by 2. Y equals a negative 9. Okay? That is now my ordered pair. X is 6. Y is a negative 9. And I've got my solution to my system of equations. Now, what I have to do is I have to go back into both equations, plug these in to get a check step. All right? So 4 times my x, which is 6, plus 2 times my y, which is a negative 9, equals 6. 4 times 6 is 24. Plus 2 times a negative 9 is a negative 18, equals 6. 24 plus a negative 18 is 6, equals 6. And check. All right, let's plug it into my second equation. A negative 2 times 6 plus a negative 2 times a negative 9 equals 6. A negative 2 times 6 is a negative 12. A negative 2 times a negative 9, a negative times a negative is a positive 18, equals 6. A negative 12 plus 18 is 6, equals 6. And check. Okay? Now you noticed, since these were opposite, I was able to add to get this middle term to cancel out because I had one positive, one negative. Added those together and they canceled. All right, here's my second system of equations. Y equals 3x plus 4, y equals x plus a negative 2. Well, in this case, my y's both have the same coefficient, which technically is 1. All right? But I can't, they're both positive though, so I can't add them together. If I added them together, I would get 2y. So this time, instead of adding, I'm going to choose to subtract. But when I subtract, I am going to do it the entire way across. The easiest way for you to remember that would be to do keep, change the whole way across. So keep, change, I'm going to change the whole way across. All right? Now, I now can say a 1y plus a negative 1y is 0. You see, I've now converted that to adding because I did keep, change the whole way across. So 3x plus a negative x is 2x, and 4 plus 2 equals 6. All right? Now this is problematic because my variable and my whole number are on both on the same side, and I want one on one side, one on the other, so I can solve. So I'll simply subtract 6 from both sides. Not a problem. And I get 2x equals a negative 6. I divide both sides by 2. I get x equals a negative 3. All right? Now, I go back up into either one of my equations. It doesn't matter which one. I'm going to pick my my second equation just because it's easier. Okay, and if you remember, it was initially y equals x, which is a negative 3 plus a negative 2. That was my original equation. Remember, it was y equals x plus a negative 2. Okay, we put the assumed 1 in there. I wanted to subtract it. I wanted to subtract it the whole way across, so I said keep, change. So I said plus a negative, and a positive. See how I changed it? But the original equation was y equals x plus a negative 2. So y equals a negative 3 plus a negative 2 is a negative 5. And there is my ordered pair. Now, don't worry too much. You can go over this video as many times as you need to see that. You can backtrack, rewind, whatever. But I've also done these two problems step by step on Google Slides. So you can look at it again, seeing what happened step by step. All right? Now, I've got to go back into my two original equations and plug this in as my check steps. So I have y, which is a negative 5, equals 3 times x, which is a negative 3, plus 4, a negative 5, equals 3 times a negative 3 is a negative 9, plus 4, a negative 5 equals a negative 5, and check. My second equation was y, which is a negative 5, equals x, which is a negative 3, plus a negative 2, negative 5 equals negative 5, and check. If you would do the check steps, you will always guarantee your answer. Guys, tomorrow I have to go into the school. I'm doing this on Sunday. I have to go into the school from 9 to 12. So if you have a question, go ahead and email me. I'll try and get back to you as soon as possible. I will be in the building, so I don't know how much computer access I'll have. But if you have any questions, again, both of these problems are in your notes step by step, and you can review this video. Okay? If you do your check steps, you'll be just fine. Take care, guys. Bye-bye.